Imagine a place where gravity is so strong, not even light can escape. A place where time slows down, and the laws of physics break apart. These are not scenes from a science fiction movie, they are real. Today, we ask one of the biggest questions in the universe. How are black holes formed? Welcome to Factnology, where we explore the mysteries of space, science, and the future of humanity. And before we dive in, make sure to subscribe to Factnology, because knowledge today could mean survival tomorrow. Now, let's unravel the secrets of black holes. Black holes are regions in space where gravity is so strong that nothing, not even light, can escape. Think of them as cosmic traps. They don't pull everything like a vacuum cleaner, but anything that comes too close, gets caught forever. The idea of a black hole sounds terrifying, but the way it's born is even more fascinating. Every black hole's story begins with a star. Stars form inside giant clouds of dust and gas, known as nebulae. Gravity pulls this material together, and as pressure builds, nuclear fusion begins, the process that powers every star. Our own sun was born this way around 4.6 billion years ago. But not every star's life ends the same way. Most stars, like our sun, are medium-sized. They will eventually fade into white dwarfs. But massive stars, those at least 20 times heavier than our sun, live short, violent lives. They burn through their fuel quickly, shining brighter, hotter, and dying younger. For them, death doesn't come quietly, it comes with an explosion. When a massive star runs out of fuel, its core collapses under its own weight. The outer layers are blasted into space with unimaginable energy, a supernova. For a short time, this single dying star can shine brighter than an entire galaxy of billions of stars. But while the outside explodes, the inside tells a different story, a battle between gravity and pressure. If the star's leftover core is less than about 1.4 times the sun's mass, it becomes a white dwarf. If it's heavier, but less than about 3 times the sun's mass, it becomes a neutron star, an ultradense city-sized object. But if the core is larger than 3 solar masses, gravity wins completely. It collapses infinitely into a single point, a singularity. That's when a black hole is born. The border of a black hole is called the event horizon, the point of no return. Cross it, and escape is impossible. It's not a wall or a surface, but a boundary where the escape speed is faster than light. For an outside observer, anything falling in appears to slow down and freeze. But to the falling object, it's a one-way trip to the unknown. Not all black holes are born from stars. At the center of almost every galaxy, including our Milky Way, lies a supermassive black hole. These giants weigh millions or even billions of suns. How do they form? Some theories suggest they grew by swallowing stars and gas clouds over billions of years. Others suggest they might have formed right after the Big Bang. Black holes don't just sit quietly. When gas, dust, or stars fall into them, they form an accretion disk, a swirling storm of matter heated to millions of degrees. These disks can outshine entire galaxies. Ironically, black holes, which trap light, often appear as the brightest objects in the universe. In 2019, humanity captured the first real image of a black hole in galaxy M87. It showed a glowing ring of hot gas surrounding a dark shadow, the event horizon. This was proof that something Einstein predicted over 100 years ago was real. Since then, we've also imaged the black hole at the center of our own galaxy, Sagittarius A. Einstein's theory of relativity tells us that gravity bends time. Near a black hole, time itself slows dramatically. If you orbited close to a black hole for just a few hours, decades might pass on Earth. To you, only minutes passed. In a way, black holes are natural time machines. Black holes push the limits of physics. Some theories suggest they could connect distant parts of the universe through wormholes. Others propose they might even be gateways to parallel universes. Some scientists think the Big Bang itself may have been born from a black hole-like singularity. The deeper we study them, the stranger the universe becomes. Should we fear black holes? Not really. The closest known black hole is thousands of light-years away, far beyond our reach. But studying them teaches us more about gravity, quantum mechanics, and the fate of stars. In a way, black holes are not destroyers, they're teachers, showing us how the universe really works. Black holes are not just cosmic monsters, they are mysteries waiting to be solved. They show us that the universe is far stranger and more powerful than we can imagine. So I'll leave you with this question. Are black holes the end of everything, or the beginning of something greater? Let me know your thoughts in the comments. And if this video made you wonder, share it with someone, and subscribe to Factnology, where curiosity shapes the future.